All right, folks, welcome to Yak Math Videos for your Calculus Chapter 4 exam review video. Today we are brought to you by Cliff Bar, Cliff Gels, New Edwardsville, sponsors of Runwell and Wang Gang, Litchfield sponsors of Chinatown Coffee Espresso, and Ultra Running Shoes. All right, folks, we've gone through a lot of these in class. Anytime it says find local max and min values on the interval, you just have to find the critical values, take the derivative of the function, set it equal to 0. Make sure that your critical values fit into the interval. All of those are between -2 and 2. And you have to test both the beginning point and end point of your interval and the 3 critical values that I found there. So we plug all those back into the original, always back into the original. Notice I have 2 ties for max and 2 ties for the min. Okay, so I have local max is there, local min's right there. Next one, take the derivative. All right, notice how when I set it equal to 0, I get plus or minus 2. Don't forget about that. -2 is outside the interval, so I don't keep it. I test 0, 2, and 5. There's my max and min. We talked about the trig one. We can all at least take the derivative. Set it equal to 0. 2 sine x is 1, so divided by 2 sine x is 1/2. Okay, if we look, sine is positive, like y is positive, first and second quadrants. So pi 6, 5 pi 6 is when sine is 1/2. I got to test 0 and pi, so I put that in the original. So the original is right there. X plus 2 cosine x. Anyway, I think my my highest value is the pi 6 plus root 3, which is that. So my lowest value is the, what is that, 5 pi 6 minus root 3. All right. Anyway, pause that if you need to. That is the trig derivative you might need to know. Next one, folks, is just critical values. Critical values are simply when you set when the derivative point when the derivative is 0 or undefined. So in this case, nothing will make it undefined. Take the derivative, set it equal to 0, plus or minus root 3. There's no interval to worry about. Here, folks, the derivative of e to the x is e to the x, and then got to take the derivative of the exponent, which we did there. Remember, e to anything will never be 0. E to any, x there is never going to be 0, so you just simply set -8x equal to 0. That gives you 0. Same thing here, folks. We need the product rule. Take the derivative of the first term times e to the x plus x squared, the first term, times the derivative of the second. Factor out the x, e to the x, they both have in common. This will only be 0 when x is 0. This term is 0 when x is -2. You have 2 critical values there. This next one, derivative of natural log, is 1 over what's inside that parentheses times the derivative of what's inside that parentheses. Set it equal to 0. Notice that x squared plus 1. Remember, you have to find where the derivative is undefined, so you have to check the denominator there. That will never be 0 because you're going to get plus or minus I. So just set the top equal to 0, you get 0. And on 7 here, folks, take the derivative. All right. You're just going to have to use the Pythagorean Theorem. Not Pythagorean Theorem, the quadratic formula. Going to have to use the quadratic formula. There is your answer. All right. 8, mean value theorem. Mean value theorem is right there. F prime of C is f of B minus f of A all over B minus A. You can do 2 things first. I mean, you can literally take the derivative first. This is the derivative. Up here, f of B, so B would be 5. F of 5 is 163. A would be -1. F of -1 is -11. So do 163 minus -11 over 5 minus a -1. It's 174 over 6, which is 29. So it's equal to 29. That's always going to be a number, okay? Move the 29 over, so you got minus 22. Divide everything by 2, then we have to use the quadratic formula. Now, you always get plus or minus, but you got to make sure it fits in the interval. So do 5 plus root 157 divided by 6. Do 5 minus root 157 divided by 6, and you notice only the positive one fits in that interval, -1 to 5. All right, number 9 here. Take the derivative. It is 6 minus 3x squared. Over here, find f of 4 and f of 0, -32 and 8. -32 minus 8, so all over 4 minus 0. That's -10. Move the 6 over, subtract it. Divide both by -3. You get x squared is 16 over 3 plus or minus, but the minus doesn't count because it's got to be between 0 and 4. So 4 over root 3 is your only c value there. All right. Find where each function is increasing or decreasing. So we have 10 on this page right here. Low d high minus high d low. All right. So it simplifies to be x squared plus 1 over x squared. X squared plus 1 is undefined, so your only critical value is when the denominator is 0. All right. So x is 0. This bad boy is going to just be totally increasing there. Okay. Plus plus again, plug it into your derivative. All right. Take a look at number 11. Right there. Again, low d high minus high d low over low squared. That is the quotient rule. You get negative 2x over x squared plus 1, all of that squared. Notice that the denominator won't be 0 because x squared plus 1 equals 0. Gives you an undefined, gives you I. Set negative 2x equal to 0. X is 0 is your critical value. All right, so negative infinity to 0, 0 to infinity. Again, plug it in right there. When you plug a negative in, that's going to be positive. Plug a positive in, that's going to be negative. So you have an increasing negative infinity to 0, decreasing on 0 to infinity. Here's number 12. Again, take the 0, factor out the x squared, and have x squared is 0, so x is 0. 4x minus 3 is 0, so x is 3/4. So you have two critical values, so you have three regions. All right, so as such, again, plug it in right there. If you plug in like a -1, positive, negative, decreasing. Plug in like 1/2, positive, that's going to be negative, so it's decreasing again. Plug in like 1, positive, positive, increasing. All right, so there we go. There's your answer. Folks, let's see, move on to 13 here. I believe that's where we have to find it all. We've got to find it all. So you're going to have one of these tomorrow. The intervals of increasing, decreasing, the local min max, concavity, inflection point. Find the first derivative. All right, so your two critical values there, 6 and -3. Those are your three intervals. Again, pause this whenever you need to. Those are your three intervals. You plug a test value that fits into those intervals in right here. All right. And if it's positive, the product there, that's going to be increasing. We've got decreasing and increasing. If something goes from increasing to decreasing, that is a potential local max. If it goes from decreasing to increasing, that is a min. So that's the intervals on increasing, intervals on decreasing. So max is at -3. Plug it back in there. I think we did that in class. You're going to have to do that. Local min is 6. Plug it back in there, whatever that is. Then for concavity, we take a look at that first derivative and we take the second derivative. So 12x minus 18, set it equal to 0. X is 3/2. So test negative infinity to 3/2, 3/2 to infinity. Again, plug it in right there. Like plug in 0, you get a negative. Plug in like 2, you get a positive. Concave down, concave up. Inflection point at 3/2. Plug it back into the original. All right, got plenty of time for that question tomorrow. And folks, again, we're going to have to be sort of quick here for the last few problems. Number 14, again, take the derivative. Those are your two critical values. All right, so negative infinity 2, 2 to 4, 4 to infinity. You have an increasing, decreasing, increasing. So increasing and decreasing, that means you have a max at 2 something. Decreasing and increasing, that means you have a min at 4 something. I did plug those into the original. That's what you get. Then with that derivative right there, take the second derivative. What is that? 6x minus 18. Set it equal to 0. X is 3. All right, negative infinity 3, 3 to infinity. You have concave up, down. So inflection point at 3. Plug it back into the original, 3/18. All right. And number 15. There's a function. Take the derivative, factor out the 3. Then you have a nice answer of 5 and 1. Two critical values, 3 regions. 1 is going to be a maximum. Plug 1 in, you get 0 to the original. Plug 5 in, you get -32 into the original. Take the derivative again, and it's another x equals 3. All right. Concave down, concave up. Inflection point at 3. Plug it into the original, negative 16. Again, pause this whenever you need to. Be a tad quick here. And 16. All right, related rates. Remember, you're going to have 2 of these. 25-foot ladder. So let's draw that. It's leaning against the wall. We know Pythagorean Theorem is in play. All right. The ladder begins to slip away. It's slipping away at a rate of 0.8 feet per second. It's going away, so the x distance is getting bigger. 0.8 is dx dt, and it's positive. How fast is it sliding down, dy dt, when the top is 15 feet above? That means that's 15. You have to do the Pythagorean Theorem off to the side, right there, to get 20. X is 20. All right, dy dt will be negative, but we'll find that in our answer. The ladder is constantly 25, so that derivative for x squared, that derivative for dz dt is going to be 0. All right, Pythagorean Theorem, that's the formula we're going to take a derivative of. Again, z is constant, so its derivative is 0. Divide by 2. Again, x is 20. That's the derivative of dx dt. Plus y is 15. dy dt equals 0. Move things over. dy dt is negative 16 over 15 feet per second. Again, we did all of these today in class. Air is being pumped into a spherical balloon at a rate of that. So dv dt is 24, positive 24. Okay, so first off, we need dr dt when the volume is that. So the volume